Machine learning. Machine learning, ML, is a subset of artificial intelligence techniques that gives computers the ability to learn from experiences and data, without being explicitly programmed, and make predictions. In another word, machine learning systems learn how to combine input to produce useful predictions on never-before-seen data, and improve their performance over time. Goals of machine learning. The goal of machine learning on the whole is to understand the nature of learning and build learning capability in computers. In depth, its objectives encompass, but are not limited to: make the computer smarter and more intelligent, develop computational models of human learning process and perform computer simulations, explore new learning methods and develop general learning algorithms independent of applications. Types of machine learning. Machine learning techniques are divided into three major categories, which correspond to learning paradigms, depending on the nature of the feedback available and accessible to the learning system. A. Supervised learning. Supervised learning is a machine learning technique where the algorithm learns to predict using labeled data. We have labeled data as inputs, outputs, and the goal is to learn a function or general rule that maps inputs to outputs. Supervised learning algorithms mainly encompass two types: classification and regression. Classification algorithms are used when the outputs are restricted to a limited set of values, i.e. predict discrete values, and regression are used when the outputs may have any numerical value within a range, i.e. predict continuous values. Some methods used in supervised learning include linear regression, logistic regression, naive Bayes, decision tree, random forest and support vector machine, SVM. B. Unsupervised learning. Unsupervised learning is a machine learning technique where the machine is trained using unlabeled data. We have only unlabeled data as inputs, and the goal is to learn some underlying hidden structure of data. Unsupervised learning algorithms mainly encompass clustering, association rule mining, dimensionality reduction and density estimation. B1. Clustering is the assignment of a set of observations into subsets, so that observations within the same cluster are similar according to one or more predesignated criteria, while observations drawn from different clusters are dissimilar. B2. Association rule mining is a rule-based machine learning method for discovering interesting relations between variables in large databases using some measures of interestingness. B3. Dimensionality reduction is a process of reducing dimension of variables under consideration or feature set, also called number of features, by obtaining a set of principal variables. In another word, it is a process of finding the axis along which the training data has the most variation. B4. Density estimation is the process of estimating the underlying distribution of data. Some methods used in unsupervised learning include k-means, dbscan, hierarchical and probabilistic clustering, a priori frequent item set mining, isolation forest anomaly detection, principal component analysis and multidimensional scaling. C. Reinforcement learning. Reinforcement learning is simply a learning by interacting with an environment to maximize a reward. It involves letting an algorithm learn from its errors to achieve a goal. In another word, reinforcement learning is based on the reward hypothesis, meaning that all goals can be described by the maximization of expected cumulative reward. There are three methods to implement a reinforcement learning algorithm: value-based, where the goal is to optimize a value function; policy-based, where the aim is to optimize directly a policy function; and model-based, where we model the environment. Some methods used in reinforcement learning include Markov decision processes, MDPs, Q-learning, Monte Carlo methods, reinforce algorithm, policy optimization, policy gradient methods, and actor-critic methods. Popular algorithms of machine learning. Linear regression, a supervised learning algorithm used to predict values within a continuous range, by establishing a line of best fit or regression line, represented by a linear equation y equals x plus b. Logistic regression, a supervised learning algorithm used for binary classification rather than predictive modeling, by predicting the probability of an event by fitting data to a logit function. Naive Bayes, a set of supervised learning algorithms used to create predictive models for either binary or multi-classification, based on Bayes' theorem, by assuming that the features are conditionally independent, given the target class. Support vector machine, SVM, a supervised learning algorithm that identifies decision boundaries for separating different data classes or categories by performing optimal data transformations and finding a hyperplane in an n-dimensional space. Decision tree, a supervised learning algorithm that is used for classifying problems in categorical and continuous variables, by dividing the population into two or more homogeneous sets based on the most significant attributes or independent variables. Random forest, a collective of decision trees that is used for classification, regression and predictive modeling, where each decision tree is trained using a random sample of the training set, and the forest chooses the outcome having the most votes. K-nearest neighbor, a supervised learning algorithm for predicting or labeling an unknown data point given some existing labeled data, by considering its k-closest neighbors in the training data, based on a distance metric. K-means clustering, an unsupervised learning algorithm that classifies data into a particular number of clusters in such a way that all the data points within a cluster are homogeneous and heterogeneous from the data in other clusters. Principal component analysis, PCA, an unsupervised learning algorithm and a linear dimensionality reduction technique used to transform data into a lower dimensional space while retaining as much variance as possible. A priori, an unsupervised learning algorithm and a traditional data mining technique used for pattern recognition and predictive modeling, particularly in the field of association rule mining to discover association rules between item sets. Gradient boosting, an ensemble algorithm that combines the predictive power of several base estimators to improve robustness, where an iterative process gradually reduces the model's errors, leading to the generation of an optimal final model. Applications and top trends of machine learning. Machine learning is broadly used in every industry and has a wide range of applications. The importance of machine learning can be understood by the following important applications. Automation. Facilitating the automation of systems stands as a notable application of machine learning, where it enables machines to perform repetitive tasks without human intervention. Healthcare. Machine learning helps healthcare researchers to analyze data on patients' conditions and give accurate insights for better results of patients. Banking and finance. To reduce error and time, machine learning is widely applied in the banking sector such as fraud detection, portfolio management, risk management, high-frequency trading and risk credit score detection. Transport and traffic prediction. Machine learning is widely used by all individuals in their daily routine by helping them to ensure highly secured routes, predict vehicle breakdown, driving prescriptive analytics, etc. Image recognition. One of the most common applications of machine learning is used to detect the images, consequently widespread utilization in tagging and face detection and recognition. Speech recognition. One of the biggest achievements of machine learning applications that enables users to search content without writing text or in other words search by voice. Recommendation systems. Machine learning helps various e-commerce and entertainment companies to digitally advertise and recommend their products over the internet, based on users' interests or past experiences. The other applications of machine learning are in virtual personal assistants, sentiment analysis, optimization, email spam detection, self-driving cars, stock marketing and trading, language translation and so on. Thanks for watching.